more we cool, the more we heat the planet. So we need to get out of this cycle. We really do. Otherwise, it's really going to be catastrophic for our planet and our health.
We have to look at cooling as something incredibly important, just as much as renewable and clean energy. Cooling is the next frontier.
You hear that? Well, there are currently 1.6 billion of these in the world right now, and I don't mean the crickets. I'm talking about those appliances that we install in our homes and offices to keep us cool and make life more bearable when the temperature climbs. Of course, I mean the air conditioners. Yeah, what do we know about air conditioners? Well, they're very energy intensive, accounting for about a fifth of the total electricity used in buildings around the world, and demand for these machines is only expected to grow as the planet gets hotter. You could call it a cooling conundrum. Ironically, the more we use air conditioners, the warmer the planet will get. But what if there's another choice? A smarter way to design our cities and homes to keep cool? That's one of the questions we'll be looking at in this episode. I'm Neil King, and you're listening to DW's Environment Podcast on the Green Fence. Now, scientists tell us that average global temperatures could rise by 1.5 degrees in the next decade if emissions aren't cut. Now, 1.5 degrees, that may not sound like much, but in certain places that are already sweltering, such as in Asia or Africa, that increase can make a very big difference. Heating is occurring at twice the global average in urban areas. A report published by the UN said the average city could warm as much as 4 degrees Celsius by 2100 if greenhouse gas emissions aren't cut back. And keeping cool isn't just a matter of comfort. Overheating can affect our health, our economies, and even our very survival. So there is a lot at stake here.
If we don't act on this, we're going to see a significant scale in greenhouse gas emissions. So we're going to have a doubling of greenhouse gas emissions by 2030. And what that means is that we're going to have huge impacts in terms of extreme heat. Beyond 1.5 degrees of warming, more than 2 billion people could be vulnerable to severe heat waves. It can result in huge impact on our labor productivity, on our workforce, if we don't also work to adapt to the temperatures that we're already seeing increase, and especially due to the urban heat island effect.
That's Lily Riahi, a program manager at the UN Environment Programme and the coordinator for the COOL Coalition. Really like that name. That's a network of stakeholders from cities, government, civil society and business that wants to accelerate sustainable cooling. And Lily is based in Bangkok, and she joined me for a Zoom call to talk about, this huge challenge that we face when it comes to cooling our homes amid global warming.
AC is really energy intensive. It's dependent on the grid, which is currently, unfortunately, largely fueled by fossil fuels in most countries. And another point that people don't always think about, they may have heard about AC being, a driver of emissions, but AC also rejects waste heat into the outdoors. And so it contributes to this excessive warming we see in urban areas, which this from AC is adding 1 to 2 degrees in some cities. And it really can undermine our energy transition because the amount of demand that we're seeing for cooling, I know that it was 2016, 17, 18, and probably last few years as well, where the amount of new gigawatts of solar capacity that was added to the grid was basically superseded by the amount of demand just for room air conditioning. We don't want to use all that renewable energy for air conditioning, right? And so that's huge. And on top of it, you have, as I mentioned, massive peak load where space cooling is going to be contributing to 50% of that peak. So you're going to have grid failures. Just to give a figure, by 2050, their estimates say that just space cooling will account for 30 to 50% of peak electricity in many countries. And today, the average is 15%.
This is a problem we should really be addressing right now and vehemently, right?
Yes, really vehemently.
Is that happening?
it's catching attention. I think a lot of champion cities are starting to tackle this, but it's not happening as fast as we need it to happen. No, it's not anywhere close to where we need to be.
So what are the main obstacles there, Lily? Is it just purely a financial obstacle, or why isn't this, being addressed as it should be?
Oh, well, there's quite a bit of obstacles. You have things like information, a lack of information or awareness. So people are not sensitized to the need or the benefits of sustainable urban cooling. There's a lack of information on practices and tools available, lack of skills to implement the solutions. So this awareness element and capacity element is a very big one. And then you have a lack of supportive policies and regulations. People are looking at what's the cheapest thing that they can buy in terms of, for example, ACs, and they're not looking at, or they're not incentivized to look at the longer term benefits, which, over the life cycle, a more efficient product will be actually more cost effective, but of course the upfront cost can be higher, and that makes it complex.
So part of the problem is also, if I understood you there correctly, that people often only just treating the symptoms. They get hot, so the solution, or the simple solution, would be, okay, I get an AC, which is, it's a vicious cycle, environmentally speaking. Yeah. I mean, if we look at the solutions that the Cool Coalition that you're part of, that is, advocating for low-cost sustainable solutions, can you perhaps take us through some of the solutions that you think are the most promising?
What we try to do is take a multi-pronged approach. And we try to promote an approach that looks at first reducing heat at the urban scale, designing cities to accommodate more green, more water, better adaptation, and reduce heat, promoting wind flow, reducing waste heat. These are really important. And the second thing is really building more efficient homes that are, by their nature, also more resilient in higher temperatures. So it's also a form of adaptation. But also, of course, through efficiency, they can reduce greenhouse gas emissions. And that can include a variety of measures, such as like passive cooling, and also how the materials you're using to build the building. For example, buildings can actually absorb a lot of heat. And so you could have cool surfaces. So when sunlight hits a dark colored roof, 38% of that energy from the sun is heating the atmosphere, and 52% is heating the city air. So only 5% is reflected back. And if you put, for example, a light colored reflective roof, you could have 80% reflected back.
Let's just leave Lily there for a bit and take a look at how all this is playing out on the ground. And for that, we're going to one of the fastest growing and most densely populated countries on this planet.
Hello, my name is Bijal Brahmbhatt, and I am the director of an organization, Mahila Housing SEWA Trust, and we are based in India.
The Mahila Housing SEWA Trust aims to help poor communities to upgrade their homes to deal with overheating. That can be difficult in crowded slums where many homes have corrugated iron roofs that trap the heat, sometimes making indoor temperatures 5 degrees hotter than the outside. And one solution that they've turned to is painting roofs with white solar reflective paint. But just how much difference can something as simple as painting a roof really make? Well, more than you might think, as Bijal told me.
It immediately made a difference in the temperature inside the houses. We have undertaken studies to show that economic productivity increased by 1.5 to 2 hours once the temperature got reduced. Thirdly, I think the infants and children, it also made a difference for their education, and their attention on studies was much longer as compared to before.
What sort of reactions are you getting?
So based on the technology, it will decrease anywhere between 2 degrees to 6 degrees. And 2 degrees here in a very, very hot country is a tremendous difference. And 6 degrees, it's almost like a cooler. But I think the first reaction that they will give if there has been a significant difference is that, we do not have access to air conditioners, but it's almost like having an air conditioner now. That's the first thing that they'll say. The second thing, and which is much more prominent, is we don't use fans now, so that reduces our electricity bills, and that's a huge saving that we are having. Third is that the general happiness amongst the family, the well-being level has increased quite a lot. So that's the first reaction.
Now that to me is quite striking. A temperature decrease that feels like air conditioning, especially in a hot country like India, where many people who are worst affected by heat, those living in urban slums, they simply can't afford an AC. Now, if we have a look at some of the stats globally, over 90% of people in the US and Japan have an air conditioner. That's compared to less than 10% of people in India and under 5% in sub-Saharan Africa. But more frequent heat waves, population growth and rising incomes in developing countries, they're expected to lead to an explosion in demand for cooling. A UNEP report predicts that millions of people in the increasingly affluent lower middle class will buy air conditioners in the next few years. And the bulk of those machines will likely be the cheapest and least energy efficient. One of the biggest AC surges right now is happening in India. And we tend to forget that all these devices, they need to be powered, right? So, there's a very interesting stat here. According to the International Energy Agency, energy demand from air conditioners is expected to triple by 2050, consuming as much electricity as all of China and India do today. So just let that sink in just for a minute. And by that time, the IEA predicts there'll be 5.6 billion air conditioners, 4 billion more than there are right now. Now, as Lily from the UN Environment Programme told us earlier, this is inevitably going to pile pressure on countries' electricity grids and drive emissions up. It's something she's already seen happen in certain areas, such as Vietnam.
We're working with Vietnam, and they're now have entered middle income as a middle income developing country now. What does that mean? What do they say to us? That also means that they're having a massive amount of people going out to buy ACs, right? What that's resulting in is a huge cost to the country in terms of blackouts and power reliability and cost of equipment and energy bills. It's not about telling developing countries, oh, you shouldn't do what we did and you don't have the right to have AC. No, you should have AC, but AC doesn't have to mean the cheapest air conditioning on the market. AC can mean thermal. It should be about thermal comfort. It should be about how can we design our cities and buildings to reduce the demand for cooling in the first place. And it can mean also finding ways to create incentives to bring the most efficient technologies to market. I know in India, for example, they made 24 degrees as the default on room air conditioners that are sold. So, there are various really creative and great policies and regulations that are powerful, but they need to be scaled up.
Right. It's also, as you just described, it seems like we need a change of mindset. We somehow have this kind of fetish, don't we? That, if it's technology, it has to be technological. It has to have an on and off button, and only then does the solution work. But there are solutions out there that can cool our houses without any buttons or high tech, right? In certain regions.
Absolutely. It's a very good point you make. And I think it's across the board. People, I think in general, have a technology fetish. Even when you look at climate change, it's always like thinking about, how can you solve the problem with, crazy technology interventions like mirrors in the sky or whatever. But, rather than looking at how to change our behavior or do some things that may change a little bit the way we're used to living. Planting trees, for example, is a solution that cities have used, and it is helping reduce temperatures.
Okay, so trees are great. I love trees, but they're not the silver bullet in this context. We also need to rethink the actual structures that we build if we want to survive global heating, ideally without any power-gobbling ACs that are just causing more emissions. This is something that the architect Sarah El Battouty is passionate about. She works in Egypt, where temperatures can reach into the late 40s in summer. She's the founder of green architecture and design firm ECOnsult, and she's also a senior advisor to the Egyptian president on climate change and sustainable community development. Yeah, and she's certainly got her work cut out for her in Egypt.
We're in some sort of vicious cycle. You have a growing population in Egypt. We're over 100 million people, and these circumstances are applicable to the MENA region in general. You have a very young population. They all require housing. The cities are overcrowded. There is continuous new construction. People are spending more and more on their assets. They are also consuming a lot more, and they have more emissions emitted out of each household as incomes rise.
It also gets very hot in Egypt. What can you tell us about what's happening there now, in terms of preparing communities for rising temperatures in the future?
Rural communities tend to know how to adapt their housing and the way they built from years and years ago, just as they've done with the agriculture. It is the urban communities that are in a state of shock because, they've moved in since the 1950s and 60s into these cities. They're very crowded. And there's always the solution of air conditioning. 30% of people's household income is going into cooling. Now, if our role as architects is to design buildings that can reduce this loss in the income, that's a success measure in itself. So you're also reducing the cost, and you're also lowering the pollution caused by these appliances. We have to look at cooling as something incredibly important, just as much as renewable and clean energy. Cooling is the next frontier. We don't have heating in homes in our region, but we do rely on ACs, and they're on for about 8 months. The hotter it gets, the longer the summers, the more people will be looking at solutions like the air conditioning, wasting their money on it. So we have to question the housing sector itself. Is it built to mitigate heat or not, in order to improve on this massive problem that we are facing?
How do you, as an architect, see this challenge? Just how big is this challenge?
The challenge is immense, because for the longest time as architects, we have been celebrated for engineering excellence. We have been celebrated for design, for pushing the limits. And only very recently has the architecture and construction industry been questioning our role and what sort of role do we play in the climate fight, and how accountable are we, and how much emissions are owed to our industry, and what we can do about it. So it's a fairly new paradigm, a shift in the traditional thinking that only the industries, the heavy industries, etc., are the ones responsible. We as designers have a huge challenge because we are the creators of these spaces. Architecture can no longer be isolated from its context and hence from its environment and how it contributes to the community around it. It has a larger role to play now. I'm very proud of this. I'm very happy about this because I feel it's a new renaissance that we're talking about the role of architecture in the climate fight.
Sarah's consultancy is currently helping to upgrade homes in 4,000 rural villages in Egypt. And these are communities with a total of around 58 million people that rely on agriculture. And some of them have lasted in the desert for a very long time. So rather than bringing in high-tech solutions, Sarah says many of the green changes they've made have been inspired by local indigenous knowledge.
When you have people that their livelihoods is based around agriculture, they're extremely aware of the challenges that they have with the weather and also the climate changes that are happening around them. This kind of inherent knowledge of adaptation to harsh conditions has existed for thousands of years with these communities, and it's inherited. It's passed down to generations. What we do is that we see which of these solutions are viable, and we integrate them, and we also educate the government about these existing resources that are around. We don't need to reinvent the wheel.
Mm-hmm. And
we've used that a lot as well in our buildings in remote areas. We've used the indigenous knowledge.
That indigenous knowledge, can you give us some examples there? What is it that they've been doing, that works so well?
So the first thing is that they build with stone, and they build with local materials that are available. The local materials that are available are always part of the topography and the geography of the region. So if it's and Egypt is very, very rich in limestone and sandstone. These are porous materials. It's very clever because the thermal quality of these of these materials serves that it is quite porous in summer.
Mm-hmm.
So it allows air to flow in and out of the walls somehow. And the way it's constructed is usually they use cavity walls. Usually the insulation is not too thick. We've learned also that lifting the building off the ground ever so slightly, as if you're putting the building on a pavement, this reduces the heat that is emitted from the ground. We've learned that entryways into houses need to be very dark. Usually the opening of the windows and the manipulated shading so that you can have a very large window in winter that allows in daylight deep into the house. But during the summer, that window shape can change entirely using shading, they build and they remove part of the wall seasonally. And it's succeeded. We've succeeded in our buildings to reduce the temperature by 10% without any mechanical assistance in the middle of the desert, by 10 degrees, sorry. So it's pretty much a clever way of having knowledge that's there. You just have to tap into it.
By 10 degrees, I mean, that's a lot, right? I mean, that is really a lot.
Yes, and we applied everything that we can possibly do for this building, reflective roofs, angled windows, wall thicknesses that do not exceed more than 30 degrees from the paintwork inside all the way to the stone cladding. It was a rigorous exercise to get every single aspect correct in order to achieve that the farmers, in this case, for a village that we designed, the people living in the village can have a cool space that is also well ventilated, and if necessary, they have fans, and these fans are operated with solar energy, but they don't need to use the fans. So it's an incredible achievement that by co-design. It's not only our design; it's literally they co-designed it with us, the community.
That's also what I find so beautiful about this. I mean, the underlying idea that in a way, your philosophy, you're reconnecting with nature and also local customs, right? It's not as if
Yes. These communities have survived because they understood, they sized up the building in its context correctly. We're supposed to be solving problems and creating things out of what we have. And I think the entire world will go in this direction sooner or later because of climate change.
That's it from me for now. My name's Neil King. Many thanks to my colleague and producer Natalie Muller and my sound engineer Jürgen Kuhn. And a big thanks to all of you out there for your interest and listening to On the Green Fence. Take it easy and take care.